ముందు ఐపీ పాయింట్ ఆఫ్ వ్యూలో సొల్యూషన్స్ చూద్దాం. ఇఫ్ యు మిక్స్ షుగర్ విత్ వాటర్ యు గెట్ sugar solution. If you mix salt with water, you get a salt solution. Likewise, what is a solution? A homogeneous mixture of two or more components whose composition may be varied. They need not be similar in quantity. One may be large excess, another may be less extent. So what is a solution? A homogeneous mixture of two or more components whose composition may be varied. It is called a solution. Sugar solution, salt solution. Why solution is homogeneous? Yes, solution always be homogeneous in nature, because every particle of the solution has the same taste, same properties. Therefore, solution always be homogeneous in nature. So, our discussion in this chapter regarding solutions is types of solutions. Types of solutions. A solution of two components, only two components present in the solution is called binary solution. That contains only two components. What is a ternary solution? That contains three components. What is quaternary solution? That contains four components. Every substance present in the solution can be called as a component. A solution of two components is called a binary solution. A solution of three components is called ternary. A solution of four components is called quaternary solution. So mostly this chapter, as far as IP is concerned, the discussion mostly about binary solution. In a binary solution, like sugar solution, salt solution, a component with less quantity is called solute. What is a solute? A component with less quantity. For example, in sugar solution, sugar generally taken in small quantity. In salt solution, salt generally taken in a small quantity. A substance with a large quantity is called a solvent. In sugar solution, water is a solvent. In salt solution, water is the solvent. You see, in a binary solution, solute plus solvent is equal to solution. In a binary solution, solute plus solvent is equal to solution. Okay, let us take another variety of solution. This is the first variety of classification. Let us go for second variety. This type of classification is based on nature of the Solvent. Nature of the solvent. If the solvent is water, it is called aqueous solution. What is aqueous solution? Here solvent is water. Alcoholic solution, in which solvent is alcohol. Ethereal solution, in which solvent is ether. If solvent is other than water, like alcohol or ether or benzene, all them treated as a non-aqueous solution. Aqueous solution means solvent is water. Non-aqueous solution means other than water as a solvent. This is another type of classification. Nature of solvent based. And one more classification, that is based on quantities of solute and solvent relatively. This type of classification is based on the quantity of solute and solvent relatively, comparatively. The first one is diluted solution or dilute solution. Diluted means the quantity of solute relatively less. Quantity of solute relatively less. Second one is concentrated solution. What is a concentrated solution? Quantity of solute relatively large. So there are three varieties of classifications. The next one more classification based on physical state of solvent. Based on the physical state of a solvent, all solutions are classified into different varieties. Let us take first variety. If the solvent is solid, what about solute? It may be solid or liquid or gas. So that based on this aspect, solutions are three varieties: solid in solid, solid in liquid, solid in gas. Three varieties. Here solute is solid in solid, liquid in solid, gas in solid. Solute solid, solvent solid. Solute liquid, solvent solid. Solute gas, solvent solid. Likewise, if the solvent is liquid, again solutions can be classified into three varieties: solute solid in liquid, solute gas in liquid, solute liquid in liquid. One more variety. If the solvent is gas, again solutions are three varieties: solid in gas, liquid in gas, gas in gas. So based on the physical state of solvent, we have collected 9 varieties, but here is a problem. All are homogeneous. All are homogeneous in nature. All are homogeneous nature. So based on the physical state of solvent, all solutions are how many types? 3 plus 3 plus 3. 9 types. These are different varieties of classifications. What is concentration of the solution? If you mix a solute to the solvent in order to prepare a solution, how much the quantity of solute dissolved in how much quantity of solvent to make the solution? That is said to be concentration. The amount of solute present in given amount of the solvent is called solution. Solution. A solution is prepared of a known concentration is called a standard solution. What is standard solution? A solution of known concentration. Known concentration means the quantity of solute known, the quantity of solvent known. Therefore, a solution of a known concentration is called standard solution. Standard solution. Now, the first topic of this chapter, that is methods to express the concentration of solution. What are the methods used to express the concentration of the solution? Okay, you prepared a solution by the mixing of solute with a definite quantity of solvent. How to express the concentration of the solution? Different physical methods are used, different chemical methods are used to express the concentration of the solution. You see, physical methods, that is weight percentage means symbolic representation, W by W percent. Here, the numerator W stands for a weight of the solute. Denominator, weight of the solution. So that weight of the solute by weight of the solution into 100. This is the weight percentage or W by W percent. Once again, numerator W stands for weight of the solute. Denominator W stands for weight of the solution into 100. How can we define weight percentage of the solution? The weight of the solute, weight generally expressed in grams. The weight of the solute present in 100 grams of the solution is called weight percentage. Weight percentage. And one more one. Volume percentage. Likewise, numerator V, volume of the solute. Numerator, volume of the solution into 100. How can we define volume percentage of the solution? The volume of the solute present in 100 ml of the solution. Once again, volume of the solute in milliliters present in 100 ml of the solution. This is a volume percentage. Second one is volume percentage. The next one is weight volume percentage. Weight W, volume V percentage. What about W? Numerator W. Numerator belongs to solute. So weight of the solute by volume of the solution into 100. How can we define weight volume percentage? Weight of the solute expressed in grams present in 100 ml of the solution is called weight volume percentage. These are the physical methods employed to express the concentration of the solution. Now let us see chemical methods. So those are very important. So before going to chemical methods, let us see a simple problem. For example, if you mix 2 grams of A with 5 grams of B to form a solution, I want a weight percentage. Weight percentage. How can we calculate weight percentage? W by W. Numerator W stands for weight of the solute. This is the weight of the solution into 100. 100. What is the solute in this mixer? Less quantity component, 2 grams. Solute weight 2. Weight of the solution means weight of the solute and the weight of the solvent. So that 2 plus 5 into 100. 2 by 7 into 100. 2 into 100, 200 by 7. You calculate. You calculate. And one more problem. For example, 200 grams of A of 25%, 400 grams of B of 40% mixed to form a solution. There are 2 components. One is A, another one is B. Here 200 grams, here 400 grams. Here 25%, here 40%. It is also a binary solution. I want to calculate a weight percentage of the solution. How much? How can we calculate? Here not 200 grams. Out of 200 grams, 25%. Out of 400 grams, 40% must be taken. So now let us see weight of the solute. So there are 2 components. There are 2 components, 200 grams, 400 grams. While calculating a W by W percent, I want the weight of the solute. In this mixer, 200 grams of A must be taken, 400 grams of B must be taken, but only 25%, only 40%. In 200 grams, 25% plus. In 400 grams, how much? 40%. How much? 50. 4 into 40. 160. Totally 210 grams. This is to be taken as weight of the solute in this mixer. What would be the weight of the solution? What is the total weight of the solution? 200 grams and 400 grams, totally 600 grams. Then how to calculate the weight percentage? W by W percent. As you know, weight of the solute, how much? 210 grams by weight of the solution, 600 grams into 100. 2 zeros cancel. 210 by 6. You calculate. And this is for objective version. This is a plain version. Once it was asked in IP examination also. So this is about the physical methods. I will give you the assignment at the end of this topic. Now coming to chemical methods. Very important. Chemical methods. Molarity, as you know, molarity symbol capital M. Normality capital N. Molality small m. Mole fraction xi, but andro kuda x అని చదువుతూ ఉంటారు. Okay, so these are the chemical methods used to express the concentration of the solution. Among these most commonly used method to express the concentration of the solution is molarity. Most accurate method is molality. It is accurate method, but inconvenient method also molality. Among these, most accurate method, most inconvenient method to express the concentration of the solution is molality, whereas most commonly used method and most convenient method to express the concentration of the solution is molarity. This is a convenient method, this is inconvenient method. This is a commonly used, mostly used method to express the concentration of the solution, but it is the accurate method to express the concentration of the solution. So here I will tell you molarity and normality comparatively. See, molarity and normality comparatively, let us see. For a solution, what is molarity? The number of moles of the solute present in 1 liter solution is called molarity. The number of moles of the solute, the quantity of solute is expressed in moles present in 1 liter solution quantity expressed in liters. So molarity, what is the symbol for molarity? Capital M. This can be defined as number of moles of the solute by volume of the solution expressed in liters. Simply. The number of moles of solute present in 1 liter of solution is called molarity. Okay, if you observe this formula, how can we calculate a number of moles? Everybody know number of moles symbol, let it be n, volume V. So molarity is equal to number of moles by volume in liter. How to calculate a number of moles, sir? Everybody knows. Number of moles, weight by molecular weight of the solute. Weight by molecular weight. Weight capital W, molecular weight, let it be small m, not capital M. Capital M already allotted for molarity. So that molarity is equal to, instead of small n, weight by molecular weight, in the denominator volume in a liter. This is the mathematical expression used to calculate molarity. You see, what are the units of molarity? In the numerator, number of moles. Volume of the solution in a liter, moles per liter, or Mole later inverse simply molar. Molar. Capital M. Capital M. Molar. And one more point. Look here. If the molarity of the solution is 1, if the molarity of the solution is 1, this is called a molar solution. If the molarity of the solution is 0.1, 0.1 means decimolar solution. If molarity of the solution 0.01, centimolar solution. If molarity of the solution 0.001 molar, millimolar solution. If it is a 10 molar, this is called decamolar. If it is 0.5, semimolar. 0.1 molar means decimolar, 0.01 centimolar, 0.001 millimolar. If it is 10, deca, half, semi, hemi or semi. And these are different varieties of solutions. Similarly, what about with the normality? Normality. The number of gram equivalents of solute present in 1 liter solution is called normality. Here quantity of solute expressed in gram equivalents, in molarity moles. Solution quantity expressed in liters, same in both cases. So number of gram equivalents of solute present in 1 liter solution is called normality. Normality symbol N. What is the formula? Number of gram equivalents of solute present in volume of the solution in liters. Let number of gram equivalents volume of the solution V. So N is equal to number of gram equivalents by volume in liters. How to calculate number of gram equivalents of the solute? Number of gram equivalents means weight by equivalent weight. How to calculate number of moles? Weight by molecular weight. Here weight by equivalent weight. Let weight is a W, equivalent weight E. So normality is equal to, instead of gram equivalents, weight by equivalent into volume in a liter. This is the expression used to calculate normality. Similarly, what are the units of normality? Units of normality. In the numerator, solute quantity expressed in gram equivalents. Volume of the solution in liters. So, gram equivalent liter inverse simply normal. N stands for normal. M stands for molar. Likewise, if the normality of the solution is 1 normal, what is called? Normal solution. Normal. If the normality of the solution is 0.1 normal, this is a decinormal. If it is 0.01 normal, same, centinormal. Here molar, here normal. If it is a 10 normal, 0.001 normal, millinormal solution. If it is a 10 normal, decanormal. If it is a 0.5 normal, semi semi-normal. The regular comparison from definition to different varieties. Okay, now, so what is the expression for molarity? Weight by molecular weight into volume of the solution in liter. Weight of the solute by molecular weight of the solute into volume of the solution in liter. For normality, weight of the solute by equivalent weight of the solute into volume in liters.